Okay, if there is no question, so we'll be in here, and I hope you can also practice, and face any problem, just simply inform me. Thank you, everyone.
It was. Thank you. It was a good. Oh, okay.
Thank you. Okay.
It was really a great experience. Thank you very much.
Thank you. Thank you. Okay.
Yeah, thank you. It was really good for me. I learned a lot of things. Thank you so much.
Thank you. Thank you.
Yeah, same here. Thank you very much. Yes, sir. I've really learned a lot.
Thank you. Okay, so basically today I take the problem solving class. Okay, and if you have any problem or any issue for your code or any confusion, you can simply share with me, then I will try to give the answer all of question. Okay. So please, one by one.
Yeah, hi.
Yeah.
Hello. I have I have some doubts regarding the exercise of land cover, machine learning random forest, because I couldn't make the graphs because it
Okay.
makes an error in image reduce region.
Okay.
So I can share my screen.
Yes, please.
So can you see my screen?
Yes, I can see. Yeah, I can see.
Yeah. Well, first of all, this is the error.
Yeah.
I
Okay.
tried to the image reduce too many pixels in the region. So I tried to make the chart regarding the area calculation, but it shows this error.
Okay, it show the error
So
too many pixel in this region. We found okay max pixel allows only for that. Ensure okay, so this is the one problem. Suppose sometime when you make the chart, and if your area have lot of pixel and mainly it across the limit, then we face this type of problem. So if you want, you can also chart. Then if you want, you can also increase your scale value. Suppose scale value is 30. If you just simply put the 100 meter, then it will work. Okay, now try to check. Just put the 100 and then check. Okay, then run the code.
okay,
So now chart is appeared, but now in this case we can also get some problem because now we computed our pixel area based on the 100 meter size of pixel size. Okay, so print, just write the print chart. Okay, print, write the print function and then put the chart variable name. Okay, yeah, just print.
I think it's well, I don't know.
Yeah,
Okay,
print chart. Yeah, now run the code. Yes, so now it's worked. Okay,
Okay.
so now but in this case we can get some problem. It's not give you the more accurate result in this time when you work with the chart, because in this time we just calculate the area based on 100-meter pixel size, but our satellite
Yeah,
image is 30-meter.
yeah, exactly.
Yeah.
And I think that's not accurate, right?
Yes.
Because
Yes.
the
Yes. Yes.
pixel
Yes.
size of the source is 30 meters.
Yes. So that's the reason we try to calculate randomly or manually without chart. Keep the 30-meter Landsat imagery pixel size and calculate the area randomly, not make the chart. Okay.
And how can do that?
Okay, so okay, just a minute. I will show you this process. Okay, so can you send me the code with your asset? Then I will show you that. No problem.
Sure.
Okay.
Well,
Yeah.
yeah, and also, well, besides that question, and I have other questions regarding the accuracy.
Yes.
Because if I don't advance, for example, my accuracy is 87%.
Yes.
If I delete, if I don't run, I did the exercise without running the NDVI,
Yes.
NDWI, and NVI, and the accuracy increases. So that's a little bit strange to me, but I don't
Okay.
know. For example,
Okay, so this problem is that in this time, this type of features we can use when you work with the complex, and then you also try to recheck your training sample. Okay, sometimes we need to increasing or decreasing the training sample after adding the before adding the different types of features like as NDVI, NWI, or NDBI. Okay, then it will also
okay.
increase, no problem.
Okay, well, let me change my screen.
Yeah.
Well, so I'm gonna share the code with
Okay.
you. So I'm gonna copy the link and send it in the chat. Okay.
Okay, and also click on your asset basically your shape file. Click on your name and then simply click on the share, and share anyone can read. Then I can easily access your boundary shape file also.
All right.
Yeah.
So the
Okay. So now also click on the asset tab and then simply click on your shape file name. Okay, then click anyone can read. Then I can easily access your boundary also. Yeah, anyone can read. Anyone can read. Now done.
okay.
Okay, so now it's okay, no problem. Then I can easily access your boundary also, and then also check the result. Yeah.
Okay.
Okay, so now I'll show you this how we can easily calculate randomly and also download the data as a CSV file. Okay, then you can easily get the idea, because sometimes art is not work when it across the limit. So let me share my screen.
Sure.
Yeah. So this is your code.
Yeah.
Okay. So now chart, if you just put the 30-meter, then we face the problem, because when I put calculate using 30-meter scale, it increase our pixel number. Okay, and it across the limit. So that's how we find out this type of problem. Okay, So then chart is not work. So then we just try to apply another method to calculate the area manually. Suppose without calculating the chart, we calculate the area. Okay. So first of all, suppose I take a variable, suppose pixel area, and basically for when you calculate the pixel area, we need to use a function, this function called dot image dot pixel area. Okay, this function we need to use. So this function, basically this function generate an image in which the values of each pixel is the area of that pixel in square meters. Okay, so just I use this function, it generate, basically it return the image. Okay, just
Okay.
paste here. Okay, and then apply the function add bands. Okay, add bands. So now this map is already stored in a variable, so just find out the variable name. So this variable name is LULC. Okay, LULC, basically this variable stored this land use land cover, so just write this variable name in here. Okay, so now we compute the total area. So just take a variable, put the variable name, suppose I put the stats, and call the area image pixel area, and I need to calculate the total area in a specific boundary. So basically we already use the function a lot of time, it's called the reduce region. Okay, to compute the minimum, maximum, or standard deviation or average. Okay, for a specific boundary, then we need to use this function, reduce region function. Okay, so now we calculate the total area. Okay, total area. So that's, I simply call this function, and now put all of argument. So I just make a dictionary, curly bracket start, and also curly bracket int. So now reducer, I want to calculate the total area. So put here dot reducer dot sum total area. Now this total area is not only for the one class, I have total all of class. Okay, water, vegetation, barren land, build up, forest. So I want to calculate the total area for all of class. Okay, so that's why I want to use a function, it's called the group function, because now I have a group of classes. Okay, and in the group, basically we find out the two argument. One argument, it's called the group field. Group field, basically one basically one column, one field. Okay, and then group name. Okay, group name, this group name, it's come from your property name. Okay, if you check what the property you use, class. So this is the property, is the class, so just I keep the same class. Okay, then geometry, basically it's your shapefile variable name. So shapefile variable name, I put here ROI. Okay, just I put here the same ROI, and I want to use here the land set. So land set 30 meter, just put, and CRS it's not need. Okay, and I also mention the max pixel because my area is big and I have some problem. So put the max pixel 1E13, and it's not need, just remove. So now print this stats and check what happened. Okay, show the problem. What is the problem? Unrecognized reducer, reduce, read. Okay, so it's showing.
No, maybe in line 147, group field should be instead of group field, group field.
Sorry, FIELD. FIELD. Yeah. Okay, so now it show the result. If you check, we find out total 5 classes. So you can see it show the result in square meter. So I need the result suppose square kilometer. So for that you can simply put here square kilometer. So for that use that the divide function, divide 1 is 6. So now it generate the result in square kilometer. So when you multiply 1 into 10 inverse 4, then we can get the result in hectare. 1 into 10 inverse 4 when you multiply, then we find out there is an hectare. Now it show the result in square kilometer. Okay, so now if you check, we find out the groups. In these groups I have a list. Suppose click on here, I can get the another list. I find out the class 0, 48.21 square kilometer area. Then class 1, 2859.46 square kilometer. So class 2, how much area? So we can easily get the area. So these things further you can also export as a CSV file. Okay, suppose it's very difficult, you can simply copy and paste, then you can easily download this type of data as a CSV. So how I can do that? So let's also try to show you this process also, how we can easily download the CSV file, this type of result. So for the CSV file, we need to convert dictionary to features collection. Okay, so we need to create the feature collection. This type of list we simply convert, or this type of dictionary we simply convert into feature collection. So let's go try to do it. Just take a variable, suppose class areas, and now I just put here ee dot feature collection function. So in the feature collection, I simply add, suppose first I want to add a list, e dot list. This list I add my stats, basically this stats, it's including all of list. So just I put the stats, and it's get from this information, get from groups. Basically you can see it show the groups. So just right here the groups. Okay, so now in these groups there are the total 5 item. Okay, 5 item. So now I create a function. So this function help me all of items. Suppose from this item it take the class and take the sum. From this item it take the class, take the sum. From this item it take the class, take the sum. Okay, so I create a function. So this function take the each item and take the result. So let's go try to create a function, and this function further is simply connect with our these groups. Okay, so this function. So for that, if you want, you can simply just I add the map for connecting this function, and also create the function keyword, and this keyword I want to connect with item. I take the suppose item. Okay, so now put the curly bracket. In this curly bracket I put my argument using this item. So what I return from here, so I take a variable, suppose item, I return dictionary, ee dot dictionary item. Okay, and in this item what I return, okay, suppose what I add in my item. So for that put here the return function, return, I return ee dot feature, and in this feature there is no geometry. Basically there is no latitude longitude, it's a null. So put here the null, and after adding the null we just put all of features. Okay, so first feature I want to add, suppose for class, basically this class. So put here the class. Okay, so this class it item, and it's get from Okay, this it's get from okay, it's get from land use land cover classes. Land use land cover classes. Okay, and we put the all up. Okay, so we put the all up is the same class. Okay, no problem. We try to put here the class. It's get from this class. Okay, class, because our property name is also class. Okay, so just put here the get it from the class. Okay, and I want to add, suppose I want to add all of result also. Suppose I want to add the result. So I put the another column. Suppose I put an area, a square meter. Okay, so take this is my another column I generate for each classes, and it also can get from item, and it's get from our result, basically sum. Okay, basically this sum. Okay, it's take this area in square meter. Okay, I want to add the another column. It show the result in square kilometer or hectare. So I take the another column name, suppose area hectare, and then this item and it's a number, so we also define ee dot number, because I want to compute the number ee dot number ee dot number, and this number it's come from this item, and get from sum, and when I divide, or for the hectare, basically when you multiply, suppose I put here that multiply 1 e inverse 4, then it compute the result in hectare. Okay, so this is my another column. So I want to add the another column, suppose in square kilometer. So for that, area, suppose square kilometer, same process apply. So I just take copy the same line and paste. I simply put here, suppose divide 1e6. So now I create this type of function, and this function, so now this is my function. Okay, this is my function. This function I simply connect with my stats. Basically it is stored all of list. Okay, so now this function I want to generate, and this function help me to compute all of classes area in square meter, hectare, square kilometer. So now I want to export it as a CSV file. So for that, same user export table to drive, and put all of arguments, suppose collection, basically this variable class areas, just copy and paste, and then description is you can put anything. I put suppose LULC area, and then file format is CSV. Okay, so now I hope it will work. Run the code. Our tux tab will be running. So from this tux tab we can easily download the CSV file, and this CSV file including all of class, number, then square kilometer, hectare, or square meter area, we can easily get from here. Okay, so this is the process, because sometimes chart is not work, then we try to apply this type of method for calculating the area. Yes, please.
Are you recording the class?
Yes.
Oh, thank you.
No problem. Okay, any question, please? Anyone have any problem or any, you can also just ask me, or any confusion
Thanks for this.
Yes.
Yeah, no, I just say that thank you for solving this issue.
Okay, thank you. Okay, we are okay. Again, any problem for the previous classes, you can also mention. Then I also guide you on a problem. And I hope you also get all of recorded session from first day to 7 days. All of recorded session I already provide, and also get all of practice code. Again, so you also try to practice. And our problem solving class, basically anytime when you face any problem, you can get it lifetime teaching, free teaching support regarding this training contents. Okay, regarding this training contents, basically our total 7 days, it complete lot of topic. So regarding any topic, if you have any doubt or any confusion, or if you try to work in your study area but it not work, then you can simply ask me question for any time. Okay, so for any content you can easily get the solution for any time. Okay, and also try to complete all of assignment, then you can easily get that e-certificate, and get all of materials I already provide, basically practice code. Okay, and also regular session already provide, so you also try to get and face any problem, then simply ask me. Okay, without Friday and Saturday, any other days before one day, you can simply knock me and take your schedule time, and then for your problem you can simply discuss with me regarding this content for any problem. Yes, please.
Uh, on the 7th day, can you please go to 7th day?
Yeah.
How can we get urban development and urban growth monitoring?
Okay, so urban development, basically when I talk in this time, in the recorded session, you also watch it. Basically in this time we talk about that urban, how we can easily work with single class change detection. Okay, single class change detection, I discussed about that, how we can easily work with urban, basically urban expansion, urban growth, how we can easily make the map. Suppose I have data in year of 1990, 2000, 2010, 2020. Suppose this type of data I have, land use land cover data. So now from this land use land cover data, I want to use only for the single class. Suppose I want to check only for the urban, how many urban expand between 1990 to 2010. Okay, so then we can easily take the single class of urban from the land use land cover from 1990, 2000, 2010 and 2020. Okay, then we make the map, so then it will be work as the urban expansion map or urban growth map we can easily generate, or urban spiral mapping. Okay, and then we can easily work with that. So just it's one kind of single class change detection. Okay, single class change detection. So basically in the 7 number session I discuss about that single class change detection, as well as to discuss about the multiple class change detection. Okay, and the single class change detection, it covered for the urban development or urban growth monitoring or urban expansion or urban spiral mapping. Okay, can you have any question please?
Yes, I also have another question regarding the urban heat island effect,
Yes.
but it's more related to interpretation than coding. Because I did the exercise in Mexico City metropolitan area, so I can share my screen if
Yes,
you
please.
if you
Okay,
like.
let me stop. Yeah, please.
So I ran the code from all these steps regarding the emissivity, the thermal, the land surface temperature, the urban heat island effect, using this Landsat 9 from the same one that we use in the exercise.
Yes.
But it sometimes it doesn't make sense to me when I see this map of urban heat island. For example, if we focus on this area, well, you don't know Mexico City, but I know Mexico metropolitan area. And if you see let me show you something. If you see the imagery, this area is a lake and this is crops, right? And
Yeah.
this is urban development and urban development. And if I click on the urban heat island, it shows a high value in the crops. So I don't know, it doesn't make sense to me.
Okay,
Why is
so
that?
yeah, this is the Arvanite Island. It show the Arvanite Island, yeah.
Yeah. UHI, and this is the UFT factor. I don't know what is this. UTF-BI.
UTF, yeah. Urban Thermal Field Variance Index, yeah.
Yeah. And this area is crops. So I don't know why this it has a high value, and this blue is water, and this area that is in green is urban. So I don't know how to interpret
okay,
that.
send me the code link. I also try to check it. Okay,
Sure.
with your asset. Also share your asset.
The asset is the same as the
Okay.
other one. As the other.
Let me share my screen.
But in some other spaces, for example, if we see if this is Mexico City central region, or in some places it works, like it works, it makes sense to me, because if you see, for example, these areas are parks or green areas, right? These dark areas, and the factor is low, and that makes sense to me. Is a little bit green,
Yeah.
and some areas that has not green areas are higher in the value. That makes sense. But in the, for example, these areas are forests.
Yeah.
These are blue, so that makes sense to me. But there are other regions that are also green areas or are not urban development, like this one, for example, is hot.
Yes.
So this is like a mountain.
Yeah.
An elevated area, for example.
Okay, this is the mountain or hilly region, yeah?
Yeah, exactly. And for example, this is the airport. This is the airport. Let me show you.
Yeah.
This is a lake.
Yeah.
And these are sand or bare land mostly.
Yes.
And also show a high value of.
Actually, barren land is also absorb the high temperature. Okay.
Okay.
Barren land is also okay, but if you check the vegetation area, if show the very high urban island, then it's some problem. Otherwise, barren land or fallow land or settlement, it also okay, no problem.
Or crops, for example, this area are crops, and you see are crops, and the value of urban heat island is high
For the crop
in
land.
some places.
Yes.
So my issue is how to interpret that.
Okay, let me check.
Yeah.
Let me share my screen. And another thing is that you also try to use the surface reflectance, not use the top of atmosphere, because top of atmosphere, this band 10 is not your reprojected, not reprojected. Okay, this thermal band is not reprojected. So in this case, I hope it also you can get the more better result if you want to use the surface reflectance satellite imagery. Okay, because surface reflectance satellite imagery, this STB10 is already reprojected and calculate the brightness temperature. Okay, but for this imagery, top of atmosphere reflectance, it's not compute the brightness temperature. Okay, it's directly show the raw band of band 10. Okay, but surface reflectance image collection, it provide you reprojected brightness, temperature. It compute all of those. Okay, so you also try using this. I hope you can also get the more better result. Yeah.
Okay. And when we use surface reflectance, we also have to scale, right? To multiply
Yes,
by
yes,
the
yes,
scale
yes, yes.
factor and all the.
Yeah.
Yeah, okay.
Then you also mentioned the scale in here. When you use the surface reflectance, then it will be look more better. I hope.
Okay.
Yeah. Okay. Okay. Anyone, any question, please? Or any confusion for any code, you can also share with me. So now you can see area, all of those it show. Okay, in CSV file. Okay, any problem, any question, you can ask me, please.
Yeah, when is the deadline to deliver the assessment?
Which one?
When is the deadline
Oh,
to
there
give
is no deadline.
assessments?
There is no deadline. You can simply do all of this assignment, okay, and then inform me. Then I will just take an interview with you and show you all of assignment together. Then you can get it, no problem. There is no deadline.
Okay, thank you.
Okay, okay. I hope there is no question. You also try to practice and also do all of assignment. Okay. Further face any problem. So without Friday and Saturday before one day, just simply knock me and take your appointment, and then discuss about your problem. Okay, regarding this course content. Okay. And not only for that, if you want to join our further online training program on so now you just simply complete our Google Earth Engine, basically machine learning, but we are also applying for the deep learning also. Okay, for the deep learning Google Earth Engine, you need to use the paid version, but we can also use some Python library and integrate with Google Earth Engine for deep learning. Okay, so for that, if you want, you can also join this course. Which one? We just integrate Python and Google Earth Engine with deep learning model. Okay, suppose convolution neural network or artificial neural network. So this type of deep learning model, how we can apply and make the different types of remote sensing analysis. Yes, please.
It's a bit weird question, but I think this course will be going on every Friday and Saturday for next batch and then next batch. So if I want to join with that class or with those people,
No
is it
problem.
possible to?
No problem. No problem. Okay. Just simply
Thank you very much.
send me your email. I also give you the access for our this upcoming batch. No problem.
Thank you very much.
Okay. Okay. So you can see this is the another training program. So in this training, we just simply combine with the deep learning, because in Google Earth Engine, deep learning is not free. Okay, they have we need to use some paid version of Google Earth Engine. But now we just try to integrate with the Python, okay, and use the Python, different types of Python library for machine learning and deep learning, for making the land use land cover classification or different types of remote sensing work. And anyone, if you want interested to join this same course anytime, you can join, no problem. For any time you can join this same course, okay, because we every month we take this course, same course. So if you want to join and learn more better all of those properly, then you can also join, but must be use the same email for your registration. Okay.